I'm really glad to, to welcome Joe Justice. So, Joe, really, really great to have you, and nice to see you in video. Let me take out this back. You are hidden. Yes, here. Now we see you.
I think that's for all these. Mic is not loud.
Test, 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 test. Is the sound coming through?
It's
Can you hear
working
me
perfectly.
too?
Yes.
Okay, good.
The sound is good.
Okay, so Joe, thanks really so much for being here and for accepting us our request to speak with us and to tell us a bit about what you did, what you're doing. So your experience. So we had like half an hour connection, myself, Charles, and Joe, in which we just explained him the amazing journey we are doing. We started yesterday, Joe, just to tell you we spent time together, enjoying, having free time, team building, dinner, a lot of alcohol. So someone may, you need to also speak loud, okay? So Charles, anything to say before to start?
No, I think we have a kind of a similar event at a smaller scale, but enjoying it so far and looking forward to hear what you have to say.
Hey, thank you. Joe, all yours.
Thank you so much. Congratulations, ABB. My understanding is the engineering teams are more involved in product definition than they were 3 years ago. The engineering teams have more permission to evolve and steer the product mix and even be involved in what will be sold and what will be developed for reuse than they did 3 years ago. And if that's true, I've heard that's part of the goal to increase that even more. What I've been asked to talk about is how we can have an engineering-led organization, how we can have agile hardware, and what might be exciting about that, and what that can do for the business, and what that can do even for the environment and making the world a better place. Are you able to see my screen? It should say rapid innovation.
Yes.
Okay, good, good. I'm Joe Justice. I founded WikiSpeed. That's the car image behind me. That's the first car I engineered and made. We made 14 of these cars and we raced them around the world. Some were actually sold to customers to drive to work, but most were race cars. We designed, built, and sold them road legal in 1 week iterations. That started in 2006. That created the agile hardware movement, where people started to believe it's possible to design, build, test, and deploy hardware in 1 week iterations, like we did with WikiSpeed. I then went on to work at Tesla. And when I was a Tesla employee, I founded the agile practice at Tesla for Elon Musk in what was then the headquarters in Hawthorne, California, in Fremont, California. When I was an employee, I then visited SpaceX in Hawthorne, California, and then Boca Chica, Texas. And I'd like to share with you what I learned, how development cycles can be short and what actually makes them short, the leadership decisions that need to be made for that to work, and why that might be a good thing. This rapid iterative development approach has been the basis for all of SpaceX's major innovations and advancements, including Falcon, Dragon, and Starlink. Relentlessly run the algorithm, challenge, delete, simplify, accelerate, automate. That's a quotation from Kiko Donchev at SpaceX. The most launches into space last year were SpaceX, more than any country. The most sold car in the world last year was Tesla, the Model Y. The most downloaded app of any type of app in the iOS and Android app stores was X, formerly Twitter. Whatever this method is, it seems to be possible and set records in software, aerospace, and hardware. And it might work with power electronics and ABB also. Step one, leadership has to replace all of project management with a great big dashboard. I think this is why this concept is not so popular. I've only seen this method in full in Elon Musk's companies. Toyota's doing some of it now. Mercedes-Benz has ambitions to do some of it. BMW and Honda have ambitions to do it. I haven't seen any company outside Musk companies do all of it. Here's what it looks like. Step one is the owner replaces all project plans, all schedules, and all deadlines with a list of the hardware products we make and one or more KPI for each product. That's the start of this. I don't know how brave ABB wants to get, but this is step one. So at least you'll know what it is. Let me get a little more specific. After retiring from Tesla in 2020, I posted a recording of an earlier version of this talk, and Elon Musk retweeted it. That doesn't mean I got everything right, but Elon didn't say I got anything wrong. The point Elon chose to amplify is that the system becomes more flat, less hierarchical. Everyone eats the same food, uses the same restrooms, etc. No executive chef or other ivory tower stuff. There shouldn't be this workers versus management two-class system. Everyone is a worker. Now, that does mean everyone had really good coffee in Tesla and SpaceX. Because if you were a visiting dignitary, you had the same coffee as everybody else. But unfortunately, it also meant everyone used the same bathrooms, and the bathrooms were not good. So we had really good coffee and not really good bathrooms. That's the result of a one-class system. Thank you, Elon Musk. First, we need to figure out what our hardware parts are. What are our products? And we split those into modules. When I say modules here, I mean pieces that aren't dependent on each other. You can build them in any order. You can design and build them in any order. Now, that is difficult. Most of us think procedurally. We'll make this module, and then we know this dependent module. Like, we can't write the software until we know what hardware it runs on. That's dependent thinking. Modular thinking is trying to have less than 10 pieces per product that we can design in any order. This is Justice's law. This is the law that got named after me. The modules of the company define the structure of the company. Now, the problem is no one knows the best modular split in the beginning. There's no way anyone has figured out to know it. We have to just start building and give the engineers permission to change the modular boundaries when they have a better idea. Agile, right? Not a big perfect plan up front, but instead inspecting and adapting. So it looks like this. This is the Tesla Semi. This is the most powerful electric truck in mass production, and it has 11 modules. These are the actual modules of the Tesla Semi. So if we were working on the Tesla seat, and that's the same seat in the Model 3 and the Model Y and the Semi, it's the same seat. If we're working on the seat, we can make a change to the seat at any time, and it doesn't change the battery pack. The battery pack can make a change anytime, and it doesn't change the seat. Or the powertrain. The powertrain just has access to more power if the battery pack gets stronger. They don't require changes from each other. In fact, there's no meetings between teams for the cooling and the battery pack. There's no meetings between teams for the heat pump and the ventilation system. Instead, they have an interface, an API to connect. As long as they stay connecting, these teams operate completely independently, these 11 pieces. Each day, teams don't look at a project schedule. They're not even told what to do. Instead, they look at this board, the Justice board, and it says the current KPIs of the battery pack. And it's those people's job to try to improve the battery pack today. So every day the battery pack gets a gram lighter, takes a second less to manufacture, costs a euro penny less to make, and it doesn't require any changes to the seat or to the center display. The project management system has been replaced by what's called the Justice board. Now, this board had no name when I worked in Tesla. When I introduced this at Toyota afterwards, I gave it a name. There's a row for each module, and engineers self-organize on a row. So engineers have to choose a row. They're not allowed to work on their own project. So leadership chooses, here are the modules, and here are the measurements, the KPIs for each module. Then the engineers themselves choose which row to work on. Each day we'd walk in at 5 a.m. Yeah, we'd start working at 5 a.m. and we'd choose, are we going to try to improve the seat today? Or the battery pack? Or the heat pump? Or the front drivetrain? Or the rear drivetrain? Or the cooling system? Or the ventilation system? Or the braking system? We would pick. Now, if you zoom in on this board, you see the metrics of merit, the KPIs for each module. Now, leadership chooses these. Elon Musk chooses these. For the center screen, here it is, the center screen and the hardware that runs it and the software that runs on it. All of these modules have hardware and software. It has a cost today. This is a real-time number reported by sensors in the factory. How much does it cost to make a center screen today? Each screen is weighed as it's manufactured. How much does a center screen weigh in grams today? And every screen is tested. How many milliwatts of electricity does a center screen draw today? What's interesting is these numbers all get a little bit better every day. In most companies around the world, we have hardware initiatives that change production every 2 years, 3 years, or 7 years. That's very normal all around the world. In Agile hardware, we actually change production every day. Every day, the parts get a gram lighter, cost a penny less, and have a milliwatt less power draw. And the engineers self-manage to do that based on the Justice board. Now, one of the things I was asked to talk about is how do we carry over technology? How do we avoid different groups of engineers building the same thing? Everyone sees the Justice board all day, all the time. It's on big monitors all around every facility. Employees can access it from an app on their mobile phones. So they see the rows that are worked on. They see the modules. And those are the modules that can be reused. So every Tesla, when I was an employee, used the same seat. There was just one seat, same seat in a Model S, Model X, Model 3, Model Y. Now the Cybertruck does have a different seat. So Tesla does have 2 seats now. But in 2020, when I was an employee, there was just one. That's because everyone could see the seats row. And they could see how many grams the seats weigh today, how many pennies it takes to make one. And the seats have electronics inside. They have airbags, occupant position sensors. They have active heating and cooling. So you could see how many milliwatts of electricity each seat consumes. Here are some of the reused modules in Tesla. The drivetrain unit. The Tesla Semi uses 4 motors from the Tesla Model S. The same motor, not a different variant, not a different part number. It is the same motor. This happens because everyone sees the same board with the motor row. There are actually two motors. Tesla does have two motors. There's two motor rows to choose from. The Tesla Semi just uses 4 of them. The heat pump system is the same heat pump for every Tesla product, and actually some SpaceX products. And the heat pump doesn't just heat and cool the passenger cabin. It also heats and cools the battery pack and the seats. It's actually the most efficient heat pump in the world now. And part of that is because there's 1.5 billion of them, 1.5 billion operational hours as of last year when this data was published. The power inverters are the same on all Teslas. There's just one power inverter row, and everyone can see it. And if anyone is passionate about improving the power inverter, they can join that project any day at 5 a.m. And then they tend to stick with it until 5 p.m., a 12-hour shift. There are 2 infotainments. The Model S and X use a bigger one. The 3, the Y, the Cybertruck, the Semi use the smaller one. And there's 3.2 million of those in use. So the economies of scale happen. When a new project starts, they don't get to make a new infotainment system. Leadership chose the rows on the board. Then engineers choose which row they work on and how they work on it. Again, here's the board. This is the real board. If you have many products, each with about 11 modules inside, the board is about this big. This is the actual board in Tesla. Toyota's doing it now. So I'm joining you from Japan because I'm working with Toyota. Actually, I'm working with most of Japan's major companies: Sony, Hitachi, Honda, Nissan, etc. Toyota is conservative. They've started with 3 modules. They want many more, but they've started with 3. And Toyota thinks even with only 3 modules, that will halve manufacturing plant investment, and that will halve development cost, because improvements could be made to the center of the car at any time, and no rework would be needed for the front and the rear. They don't need the same cadence. They don't even need to have meetings with each other. As long as the interfaces stay compatible, changes can happen to these 3 pieces at any time. This is what I mean by modularity, independence. So each of these 3 pieces improves on their own cadence as fast as they can with no schedule. There's no date. It's simply try to improve the numbers as quickly as responsible. And I think Toyota's right. I think this will halve development cost and halve plant investment. The former CEO of Toyota, Akio Toyoda, started this initiative. And I do think this takes a leadership move to start. Akio said, "We have to smash the Toyota way." I felt strongly that when I went to the field and looked at the products, I could see that the important thing was to put energy into the change points, the speed of change. These are the words of Akio Toyoda, CEO of Toyota Motor Corporation. Let's zoom in on one of these modules so you really know what I'm trying to say. Here's the heating and cooling system in the Tesla Semi. This is the same heating and cooling system in every Tesla product. They just use one. It started like this. This is very similar to the air conditioning and heating system in a Mercedes-Benz S-Class. Very similar. Some of the same suppliers are used here too. Adaptive, Bros, Bosch. Some of you might recognize some of these parts. They are Adaptive, Bros, and Bosch parts, and a few of them were made in-house at Tesla. This is the actual heating and cooling system. Then engineers join that row on the Justice board every day in the factory. In a Musk company, you're only allowed to work in the factory. So if you're designing this system, you're doing it in the factory where these parts are made. That means you can actually influence production in the same day. So every day, engineers go into the factory and try to make this thing weigh a gram less. Any part of this can we make it differently today so it weighs a gram less? Any part of this, can we make it cost a penny less? Any part of this, can we make it consume 1 milliwatt less of electricity in the factory, not in a separate design office? And over time, it gets simpler. It does get lighter and less expensive and consume less electricity, a little bit every day. And now it looks like this. That's the entire heating and cooling system for the battery pack, the cabin, and the seats. It's about the size of 2 pairs of shoes. It costs truly pennies to make. It's made like a toy by squishing plastic together. The important point here is no one knew how to make a heat pump like this before, no matter how many years we gave the engineers to design. The only way we could figure out how to make such an efficient and small heat pump was by trying to change it a little bit every day. Agile, right? When you work in a Musk company, there's only the factory. You don't have an office to come to. You go into the factory each day, and you work in a group. So you have a lot of skills to help you. It's usually 3 to 5 people. Here's the actual heat pump and what we actually did every day. And these are real pictures. So at 5 a.m. each day, we would go to where the robots are making the current heat pump, the heating and cooling system. And in a group of 3 to 5 people, we would try to manually make a prototype heat pump that we guessed would cost a penny less, would weigh a gram less, would consume a milliwatt less of power. We didn't start by drawing CAD. We started by actually melting plastic and bending metal and mixing glue, mixing epoxy. That's actually how we started each day. Then as we worked, we would reprogram the production robots. Now, there's around 10 copies of the heat pump being made at a time, around 10 groups of robots making heat pumps. So we would turn one of those sets off. So 10% of production capacity would turn off, but around 90% would keep going, making the current version of the heat pump. Then as engineers, we would reprogram that one group of robots, around 10% of production, to make our prototype. Now, we didn't know yet if our prototype was good, but the only way we got better at programming robots, the production robots, was by programming the production robots. So it was valuable to us to reprogram the robots at least once every day to increase our skill programming the robots. So as we're manually making a prototype, members of our group, 3 to 5 people, are reprogramming one of the groups of production robots. So we get better at programming robots. Another person would draw CAD. Now, we didn't start with the CAD. The CAD would be drawn after we started making the prototype. And we wouldn't draw the part. We'd draw the production steps. The reason we did this was to train Tesla's AI on what production steps are being used for this version of the part. What we wanted was Tesla's AI to learn for what kind of part, what kind of production steps make it. And then when we turn it on, Tesla AI records how many seconds does it take to make a heat pump? How many milliwatts does that heat pump draw? And it guesses how much it costs to make that heat pump. So the real value here is we're training the AI as we're designing, and this happens every day, 5 a.m. to 5 p.m. Then night shift comes in, 5 p.m. to 5 a.m., same number of people. The definition of done is we've turned on that group of robots again by 5 p.m., and it's in production again, and it's making a slightly improved version of the heat pump. Hopefully it weighs a gram less, takes a second less to make the heat pump. Hopefully that heat pump is a decibel quieter. Hopefully that heat pump in accelerated aging estimates will last at least 1 day longer before a predicted fault. Every day we do this. This is real agile, not a 2-year program, not a 5-year program. It's a 12-hour cycle. And then night shift would come and try to do it again by 5 a.m. Now, that'd be really difficult to take people with design skill and put them in a factory, and take people with factory production skill and have them design. The AI makes it a lot easier. This is a real photo from inside Tesla in Europe. This is in Germany, Giga Brandenburg. The employees work in groups of 3 to 5, assisted by AI. Some of them have production skill, some of them have design skill, and they ask the AIs questions. And the AIs get better the more questions are asked of the AIs. With that, this group can actually improve the heat pump or any of the modules a little bit every day. And over time, there's not really a division between designers and production. It's just employees. And I think that's what Elon Musk meant when Elon says everyone's a worker. Here's Neuralink in the US, another Musk company. And these mobs assisted by AI, they choose to work within 3 meters of each other if their parts connect. This reduces the risk of integration problems. When parts connect, they don't work, would be an integration failure. That's reduced when these people work within 3 meters of each other. Now, Tesla AI is really good now. You can ask it to draw an electric motor. You can say, Tesla AI, please draw me a more efficient electric motor than humans have ever made. And now it can. It will give you some good ideas. Why? Why can it do that when ChatGPT can't do that? Not yet. Google Gemini can't do that? Not yet. XAI can't do that? Not yet. Why can Tesla's internal AI do that? Every work team has one or more person in the team training the internal AI as they work every day. So Tesla AI has seen every version of the heat pump and a CAD model of the production steps to make it every day for more than 10 years. There's more than 3 billion of some of these parts in production now. And Tesla AI has a CAD model of every single one. Over time, it's gotten some good ideas. Now, Tesla also makes their own 3D drawing software. That does make it easier for the AI to draw because it has its own software. It doesn't have to integrate with Dassault or CATIA or Windchill. Tesla also makes their own magnetic modeling software, their computational fluid dynamics software. And of course, that makes it easier for Tesla AI to connect to it and use it. What's really useful here, though, is Tesla AI doesn't just draw complete motor CAD. It draws the production steps and production machinery because it's been trained on the CAD model of the production steps for every part, every day, for years. That's the real value. I don't think many people understand it. The actual value of Tesla is actually Tesla One, their internal AI. So of course, Honda is now working on Honda One, and Toyota is working on their Mob AI assisted software, their own internal AI. What Toyota started with is generative AI, so coming up with new ideas with engineering constraints. They would tell the AI, here's the bumper height that's required for this to meet pedestrian safety standards. Here's the aerodynamic constraints that are important to our car. Now AI generate spontaneous ideas that meet these constraints, these engineering constraints. So Toyota uses Mob AI now, group work assisted by AI, with their own AI tools. I'm going to get a little nerdy for just a minute. I'll get a little detailed here. When you're working in this style, 3 to 5 people one of those people, one, two, or three of those people, their primary job is to program your own AI. And it's actually very simple. They write down 3 sentences each time you get a good answer. When you're designing a heat pump, you'll type questions like, what's the most efficient heat pump we know of now? What's the most cost-effective heat pump we've made now? And often detailed questions like, this bracket, please suggest 3 ideas to make this bracket lighter and cheaper. Explain it to me like I'm 10 years old. And you'll get some answers. Whenever you get a good answer, you write down what was the question you asked. You type it down in a text file. Then what was the context around the question? Here, we're trying to make the heat pump lighter. Response. What was the response that was good? Now, writing a text file with these 3 things is then used to improve the AI, and it's automatic. This is what most companies in the world get wrong right now. They have a separate AI group that usually outsources to ChatGPT or a similar part. And they try to figure out what AI might be helpful to the engineers. And a year later or 18 months later, they have their version and they turn it on and the engineers can start trying to use it. This method, Mob AI, your AI is trained only by the useful answers you got while you're actually doing engineering. So your AI has the best data set possible. And it's actually quite simple. It's these 3 lines. I run workshops on this all around the world. Train your own AI to grow your own company. And the reason why is if we don't use AI, a company that does, an outsourced engineering firm that does, can offer faster, lower cost, higher quality services. Well, what happens if 2 engineering firms both use ChatGPT? They can't get better than ChatGPT. All they can do is compete with each other on price. And what happens is only companies that train their own AI become high price, high skill providers. And this is happening now. So what we do in Mob AI is you do ask any AI, ChatGPT, Google Gemini, X's Grok, and whenever you get a good answer, you write down the question, the context, and the response to train your own AI. Mob AI uses any AI and trains your own AI. If you use publicly available artificial intelligence, also ask the questions and share the best answers to your own AI. At Tesla, all work was group work and all work was AI assisted. We didn't use the word Mob AI. I use the word Mob AI now to try to explain it to other companies. We would train our own AI as we work, so all work becomes AI assisted for speed and quality, and is eventually completely automated so the humans can focus on new types of work. We would mob emails, so we spend less time in email over time. Contracts, so eventually some types of contracts are automated. Programming, 3D drawing, even physical work like assembling robots and building cars was done using Mob AI. Most meetings, such as daily stand-up, can be skipped if we mob with 3 to 5 people and AI more than an hour a day. We're already aligned. Mob works well with all new people or all senior people. All new people are highly creative, and with AI help, they can still get things done. Highly skilled people are great at getting things done and improving the AI. Mob is ideal for 3 to 5 people, but you can use Mob AI to train your own AI, even if you have to work alone. But it works better with 3, 4, or 5 humans. If mobs make modules or services that connect, they choose to work within 3 meters of each other. And usually they join each other's mobs sometimes, which transfers skill. I recommend remote mobs, so we save commute time and spend more time with family. That is what I recommend. However, in-person mobs are 2% faster. Physical work like building cars or building rockets must be done in person. Mob AI trains our AI on all work, our accounting, our financial reports, and of course the engineering. So if we're changing these cars every day, if there's new parts introduced into production every day, how can those be sold legally and safe? Every car tests itself. Here you can see factory mode on the display. This is a production step. Every car goes through it. The steering column is testing the dashboard, and they're asking each other, how much electricity do you use? How much do you weigh? What tests can I run on you? They're talking to each other in factory mode. And they're talking to the battery pack in the floor pan. How much electricity do you have? How many kilowatt hours can you discharge at once? Let's test that. Every car tests itself as it's assembled. Now, this is different. Most manufacturing companies have equipment that tests parts, and they test 1 out of every 10,000 parts. So as an engineer, we can't introduce a change until the next batch when we'll go through testing. If we test every part, we can introduce a change at any time because every part will be tested. But there's another piece here. We don't have a machine that tests the part. The part tests itself. This means the test never stops running. So we get early warnings if there's faults in production, in field use. We don't have separate equipment to test the parts. We always put the test equipment in the part. This gives us field detection, and it also lets us have analytics from parts in use. And this is how Tesla was able to reduce the cost of the Model 3 by 30% over 4 years. Most car companies try to constrain how much the price goes up over time. But some of you have noticed Tesla products actually go down in price over time to the customer. The customer gets a lower price. And this is why, because each part, there's around 10,000 parts in a Tesla. Each part is getting about a gram lighter, about a penny less every day. And that actually even reduces charging times because each part is consuming less energy over time. So customer experience improves. The charging times reduced, in this case, 30% over 4 years. The goal is for 100% of staff to be engineers, directly improving products and services. Amazingly, this process works in automotive at Tesla with power electronics, like small versions of what ABB makes. Pure software at X, construction at the Boring Company, medical devices at Neuralink. They're approved to be put in humans now, and they change those hardware every 45 minutes, hardware and software. It's the fastest iterating hardware product to be approved to be implanted into a human ever. And aerospace at SpaceX. SpaceX made 1,000 hardware changes to the world's largest rocket in 30 days. Ted Malaska, Senior Director of Application Software at SpaceX, says the same thing. We're looking for outstanding engineers to work in a game-changing environment. No project management. No agile. Not agile the way most of us are used to thinking about it. No architects. No designers. And we're in the office every day. No remote work. But you get to change the world and work on rockets. How could that work? How could you have no project managers, no agile, no architects, no designers? They're making the biggest rocket humans have ever made. And it already launches 90% of all mass into orbit. How is something that works so well done with None of these things. It starts with modules. You take the rocket and the launch system and you split it into modules that can be released in any order. Each one becomes a row on the Justice board. Leadership decides this. This is a leadership decision. But then there's no scheduling or project management after that. Instead, you just say, engineers, pick a row and try to make it better today. And the engineers actually get empowered freedom. It's the SpaceX and Tesla are the #1 and #2 chosen places to work on Earth for graduating engineers because of this freedom. And that has resulted in the lowest cost of spaceflight ever, because all 100,000 parts of the rocket, engineers are trying to produce them a second less today, trying to make each part a gram less today, trying to make each part cost a penny less today, and trying to increase the thrust a gram today. So of course you have iterations of every module, Raptor 1, 2, and 3. And each module gets lighter, cheaper, higher power, and simpler. And no one knew how to make this simple rocket before. The only way we could figure it out is by this iterative, agile approach. I'm Joe Justice. I race electric cars for fun. That's what I do now when I'm not working with Toyota or Honda or Mercedes-Benz or BMW or ABB. I do this because I'm passionate about the sustainable development goals and I love race cars. That's what I do. I own the largest electric race team in Japan. That's my passion. And I would love it if you'd connect with me on social media. I'd like to see if there's any Q&A. You can ask me anything and I'll do my best to answer it. Congratulations, ABB, on your Agile journey. I think it just gets faster and more fun from here. Let's see if there's any questions.
Thank you, Joe. First of all, let me clap to your speech. That has been amazing. So I'm sure there are really a lot of questions. I also have a lot of questions, but second priority. So yeah, Zeriun. And also to the team in Sweden, please open the mic and go on for questions.
Thank you for the nice presentation. I have a bunch of questions, but I will ask only one and I will give also the chance for others. The first question is, you know, to become agile, it's a journey. But did you remember the journey? If you explained that a bit better, because there is a frustration time, there is also a high and up time and things like that. So if you highlight that a bit, I promised only to ask one question, but I will ask another one, sorry. The other question is the iteration time. Let's say normally the normal agile in most organizations, it takes 2 weeks, 3 weeks, 4 weeks. You said only 1 day. How is that possible? Because I need more explanation. You touched some points, but if you elaborate that a bit, that would be nice. Thank you.
Great questions. And they connect. They connect. The journey, I think, is linked to the iteration length. So what I showed you here, that's the bottom of the 12-step workshop I run on this change journey. And how I think this works is people learn these 12 steps, and then they start with one of these steps, and their journey is to eventually implement all 12. Seems to be the solution, the best I understand it. That's my best understanding. So we did this stripe down here at the bottom, and then starts the workshop. It's a 12-hour workshop over 2 days, an hour per island. I think I have a graphic that will help me answer your question about the journey, I hope. And it's SpaceX's launch history. I might not have it in this version of the class. I don't see it where I thought it was, unfortunately. Okay, I'll try to answer it without the visualization. I wish I had the visualization. Is it here maybe? Maybe not. Okay. About the journey and the iteration length, they're linked. So the idea is we start with whatever iteration length we have now. And for most hardware companies, that's somewhere between 7 years and 3 months. A lot of hardware companies, it's 2 years or 5 years is a hardware iteration. So we start with whatever length we have, and that is our iteration length. An iteration means a new version is in production, tested, and approved. That is an iteration. Anything less than that, anything shorter than that is not a hardware product iteration. So we start with that iteration length, 2 years, 3 years. Time from budget approval to in production, on sale, approved for use. Many times 2 to 3 years, could be as long as 7 years. For SpaceX, it was 4 years. The first time from budget release to successful launch was 4 years. Now, there were many launch attempts along the way. You test as often as you can, every day if you can afford to, but time to successful launch was 4 years. Then you add automation, and that's where this mob AI concept comes from, and all the agile skills fit here. Value stream mapping, release planning, resplitting teams, introducing modules. But I'll say automation has a major benefit to speed. And then you go through your next iteration and you try to go through it faster with the same or higher quality level. I never count an iteration speed as increased if quality went down. So when I talk about speed going up, I mean with the same or better quality. So for SpaceX, the first time from budget release to successful launch was 4 years. The second time was 2 years. Why? A lot of automation was added. A lot of frequently asked engineering questions were automated. A lot of frequently done engineering steps were automated. A lot of frequently done tests, hardware tests, were automated. For example, SpaceX made their own X-ray machine and attached it to their welding machine, their welding robot. So their welding robot, as it made parts of the rocket, X-rayed the weld. So they had inspection done at the same time as welding. That saved thousands of hours total over rocket time. Now, each of these automations stacks up, and SpaceX did the same amount of work, actually a little more, in 2 years that they used to do in 4 years. That was their journey. Well, they keep adding automation, and now they're at 45-minute iterations. Now, this is more than 10 years later, but yes, they're at more than 40, they're at shorter than 45 iterations, 45-minute iterations in hardware. And I experienced that in Tesla and then when I visited SpaceX. So the journey is the iteration length. And the iteration length starts with whatever the company has now, from funding release to tested, approved, in use. And we automate and reorganize and all the cool agile practices we know to shorten that length. Did I meet your question, or did I misunderstand your question?
No, I think you nailed it. Yes, yes. Thanks a lot for the answer. And I don't know if there is another question from the team sitting in Sweden. Okay.
We have a question. Sorry, just
Yeah,
shortly. And the question is, we work with somehow tested products, right? Do you have also certified products? I mean, we know cars are also kind of certified. How do you manage this change and testing, or change and certification?
Very important question. Here's what I think. I think it's that we have to test every part instead of every 10,000 parts, because we can't release a change that's not tested. It wouldn't be safe. Then we have to group changes immediately by if they require certification or not. Some changes to a car require certification again through the world's government bodies. Many changes don't. So when we're making the heat pump a gram lighter because we folded a bracket this way instead of that way, that does not require crash testing again. That change does not require legal certification again. But some changes do. When we change the type of glass to have different layers inside to make a quieter car, then we do apply for testing in each global market. So how do we do that? Every time we ask governments for approval, we feed the results into Tesla's AI. And Tesla AI gets really good at anticipating what questions are going to be asked in response by the certifying board. So now each car in factory mode creates its own application for road legal use. Humans don't write those anymore. And it's optimized based on all the questions that have been asked from every previous approval request. This makes it very likely to be approved the first time. And the report is generated effectively instantly because it's all software, generative AI. There's another important point. Most companies apply for approval once every 2 to 3 years, depending on the product type, or 7 years. Instead, the agile approach is make a small approval request every day. And that's what Tesla does. So each car sends an approval request, potentially, saying, I'm the same as the car you've already approved. The only difference is I have different glass. Here's the tests we've run that are similar to the tests that you actually run in your test lab. Here's the results. And I think that's what you need to know. Because there's a very small change area, just the glass. Everything else is the same as already approved. So these small approval requests, these frequent small approval requests, the turnaround time is much faster.
Okay, thank you.
Thanks, Joe. That is kind of amazing. People are astonished, a bit shocked. So there is one more question here from Junaid, our agile coach, because we still have not project management, but some agile or some seniority engineers is still there.
Thank you, Joe, for the presentation. Really thought-provoking. When we talk about agile, the first thing that comes to mind is the customer. In your flow, I never heard the word customer. Where is it that you're getting the feedback from? So you said the leaders set the KPIs every day, but do you take feedback every day as well, or how do you drive your vision?
Fantastic point. And I'd like to answer that 2 ways. One is each car has analytics streaming back in real time. There's around 6 million cars on the road now, and each one reports in real time how fast it's being driven, where it is, what music is being played, the temperature, how many people are in the car, even what position they're sitting in. You can't see who owns the car or who's in the car, but you can see almost everything else. So you can see when features are not used, or when features are used often, or when it seems like people are often making a mistake and having to correct it again. Like we see that the temperature is adjusted and then immediately adjusted back, and then the stereo volume is turned up. That tells us there's probably a confusion when people are just trying to turn up the volume of the stereo and they accidentally change the temperature. So we should improve the UI. So an over-the-air update is pushed to try to improve the AI, the UI, the user experience. So part of that answer is analytics. And the analytics are really good, and everyone can see them in real time. There's no reports. There's no waiting for the next process data. Everyone can see the analytics in real time. That's part of the Justice Board coming through. Well, that's one part. But there's another part. I think some of us as Agilists know some things that Elon Musk does not know. Yes, the best-selling car in the world is a Tesla. It's a very successful company, but I don't think they're perfect. And something that I think is missing is what we Agilists have learned about customer-centered design. When I was a Tesla employee and when I founded the Agile practice in Tesla, I had no direct access to the customer at all, exactly as you said. And I think the designs and the product success would have been better if we did. So I think incorporating the customer, like we Agilists are familiar with, often through a product owner role, is a great idea and maybe something that Tesla can learn from. The real-time analytics from parts in use do help a lot, though. Did I connect with your question, or did I misunderstand it?
No, I think, yes, you nailed again. There is one more question here from the room. I don't know, Charles, if you also have someone else. It would be great if we can close with one question.
Start with yours, and
Okay,
I think
yes. Yes.
Yes, Joe, again, thanks for a very insightful presentation about Agile. My question to you is around the Justice Board and how potentially the Justice Board changes when you choose to do a new product. Because at some point the semi did not exist, but today it does. So in future, when you choose to do a completely new product, how does that align with the Justice Board? How does it influence the Justice Board?
Perfect. Perfect. Now, the complete answer would take about an hour. So I hope someday we get to do the Joe DX class in ABB. It's online. It's 2 6-hour days. And I can be more complete, but I'll try to give a useful but short answer right now. The modules are each a row, right? And then they are grouped by product. So every product uses the same heat pump, but there are still groupings for the Model 3, the Model S, the Model X, but there's one heat pump row that then points to both of those. So there's a grouping, right? When we introduce a new product, we then group, are any modules reused? And in Tesla and SpaceX, they're almost all reused. Very rarely do we introduce a new module with a new product. But then there's a new grouping put on the Justice Board, and that's a product launch. Now, the longer answer would be, how do we decide to launch a product? Because interestingly, that's actually an engineer decision. That's not Elon. But how that is done efficiently and without hierarchy is a longer answer. But I'll show an image as a teaser. There were 2 Cybertrucks originally, 2 very different designs. Elon did finally choose, but engineers just started building them. So why? How can you have complete duplicate effort in this system that I'm trying to explain is so efficient? Well, that's a longer answer. But the teaser image is there were 2 Cybertrucks that were very, very different before.
Thank you. Thank you, Joe. I know there are no more questions from Sweden, but there is a question here. You know, we also invited HR, so we are so inclusive. So we are not only R&D and, you know, technicians, but also HR is here.
Great. Thanks a lot, Joe. I wanted to also ask from the HR point of view, not forgetting the employees. So it's quite a radical change in the employee experience, the way you work. So would you talk a little bit to the way, how do you make this attractive for the people to work, also not just the newcomers, but also kind of longer term careers?
Awesome point. Very important point. First, there is HR in Tesla and SpaceX. In fact, in Tesla, there are 2 HRs. That's how important it is. There's 2. So it's a very well-funded, very important function or functions, 2 HRs. And HR in both cases works as a service to make sure that the outputs of HR are efficiently being consumed by everybody. One is HR also uses metrics. One of them is how many applications are there per open position. And that is to guess how appetizing, how exciting the open positions are. And there are currently more than 1,000 applications for every open position at Tesla and SpaceX. So they definitely don't have a problem getting candidates. They're the #1 and #2 choice of graduating engineers worldwide. And when I ask people coming in, why are you excited to work here? The first answer I got most was the mission. SpaceX isn't just an aerospace company. They're trying to colonize Mars. That gets some people really excited. Tesla is not just a car, solar, and battery company. They're trying to transition civilization to electric power so that civilization can live off Earth. Those two companies are connected. And the engineers get that. And they're really excited by that. They're like, I want to live on Mars, or I want my kids to live on Mars. Like, that's really exciting to these people. But there's another point you brought up, is what about people of every age? And I think that's where the AI collaboration is so useful. And we might not understand that right away. If you actually do mob AI, it's very relaxing because you're basically mentoring your AI assistant, and people who are really experienced often enjoy that a lot. They have this mentoring relationship, and you do it in a group of 3 to 5 people, usually of mixed ages. And the senior people typically love that. And they don't have to keep up with this young, super energetic person, because the young, super energetic person is doing. They're using that energy. They're not waiting on the senior person. And everyone gets to work at their same pace together. I think that's an artifact of the AI-assisted group work that makes it so appealing. When I worked in Tesla Fremont, there were some employees who had been employees in that same factory when Toyota managed that factory. They'd been Toyota employees before. And some of them had been employees in that same factory even before that, when General Motors managed that same factory, the NUMMI plant in Fremont, California. So some of these people were in their 70s, and they'd worked in GM, and they'd worked in Toyota, and now they're working in Tesla. And they liked it. I asked, the stock price went up a lot. How come you choose to work here? And they said, many people said, I'm excited about the mission and I enjoy the work.
Thank you. Thank you, Joe. Thanks for the answer. And I think we finished our time. So again, Joe, if you can even, okay, you have the QR code there. Thanks. So if someone of you can take a picture so that we can have later on and send on the chat. And Joe, what to say? Thanks so much. This speech was so inspiring for all of us. We will have one more speech now, and then in the afternoon, we will start rethinking on our organization. I think we need to get rid of everything we've done so far because we got new ideas today, but let's see what we could do. And thanks also to the team in Sweden for connecting, and the other guests that we had here today from the innovation team. And Joe, let's keep connected. And thanks again for everything you said.
Thank you so much, ABB. Congratulations and good luck on the next steps.
Perfect. Thanks also from our side. Thank you. Bye-bye.
Thank you. Bye. 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 Bye.